Hello everyone, we are continuing our predicate calculus flow of argument. This is the beauty of mathematics where things start interesting. So our basic focus is on the truth value of a statement. Basically we'll be talking about the conclusion statement given the preposition statement, the true statement, then we have to conclude on the truth value of the conclusion statement. So first thing first, before we do some two examples that you understand, we have to recall what we discussed on predicate calculus under truth table before. We had the implicit statement, disjoint statement, combined statement, and the conditional statement. Also have contradictive statement. So under this one, the implicit statement, you can recall that I said a false can imply a false can imply a true can imply a true, but a true cannot imply a false. So an implicit statement P imply Q. So for P imply Q to be true, it depends on the truth value of Q. So we start if Q is true, P imply Q will be true regardless of the truth value of P. So P can either be true or false. Continuously, if Q is false and for P imply Q to be true, also P has to be false, because remember the only false imply false, not true imply false, because a true cannot imply false. So that's why P has to be false. But so that's the conditions you have to know. So which means we are done with the implicit statement. We come to the disjoint statement. Q union R. It's either Q or R. So in this case, it depends. If R is true, for Q union R will also be true regardless of the truth value of Q. This Q can either be true or false. So if this Q is false, and for Q union R to be true, R must be true. Because you remember the union, either one of them or both. But if both are false, the statement will be false. You know that. So they combine the statement. P intersect R. So for P intersect R will be true if and only if both P and R are true. So this is vice versa. If P and R are true, P intersect R is true. If P intersect R is true, P and R are true. So it's combined. So the definition is biconditional, which is this one, is defined by Q if and only if R. So Q biconditional R, in this case, for Q biconditional R is true if and only if, as we do it biconditionally, Q and R are both true or both false. So last one, contradictive statement, not P. Contradicting statement, not P. Not P will only be true if P was false. So let's see how this thing went. An example. If Chino is driving, then Dimitri is hungry. Dimitri is not hungry, therefore Chino is not driving. So what we have to do here is to denote the statement Chino is driving to be statement P, and Dimitri is hungry to be statement Q. So you can see we have two statements. So Dimitri is not hungry is the negation of Q, and Chino is not driving is this one is therefore not P, is the conclusion statement. So in this case, we are given If Tino is driving, then Dimitri is hungry. So we're using P implies Q. And Dimitri is not hungry, we have not Q, then we have to conclude on not P. So what you must note is that, as I told, the preposition of the given statement are true. We just have to know to conclude on the truth value of this statement, not P. So first thing first, we know that since not Q is true, Q is false. Then we can proceed. If P implies Q is true and Q is false, then P must also be false. You recall it is point number 2. If Q is false and P implies Q is true, then P must also be false. So hopefully you got it now. You got it right? You see how interesting is this? Wow, I love this. I like it. So proceeding, since now P is false, not P is true and the statement is valid. So that's how it goes. So interesting mathematics. So is the argument flow? That's how it flows. So for you to understand much more, let's just do this last example, then we'll continue with the I already did the 2 examples on the 52 minutes video. So proceeding with the second example, we have Q or not R. Not Q by conditional, P, R. We have to conclude on the truth value of not P. So remember, these 3 given statements are always true, but we don't know about this. So we can start. If R is true, then not R is false. So since we know that our not R is false, and as we said, in this case, where we are talking that Q union not R is true, therefore Q has to be true, because already we showed that not R is false, and for this to be true, then Q has to be true. So proceeding further, if Q is true, then not Q is false. Since we know that not Q is false and not Q by conditional P is true, so P has to be false. So P also has to be false. So we are not just guessing, we are guided. These are, if you understood what I talked about this, they are very much important and I know this statement is somewhere here, it's by conditional, here it is. For this to be true, both has to be false or both has to be true. So since we know that one of them, which is not Q, is false, then P has also to be false. So we continue. If P is false, then not P is true, and the statement is valid. We have a valid statement. So this math is interesting. So you just have to understand what's going on in here. So hopefully you'll get it well. So let's try this one. Not Q implies R. So the negation of P intersect not Q. If I may recall, we talked about this. This, remember, is equivalent to, by De Morgan's, not P union Q. So you can take it this way, not to be confused. So I will treat it this way, in such a way that you'll understand, not to make it long. But if I have to give reasoning by De Morgan's, this is the same as this, I'll do that. But right now, I'll focus on these three statements being true, then we have to prove the truth of P if it's true. So, first thing first, what do we know? We know that if our not R is true, R is false. That's the first claim that we are basically having. So, proceeding. So, we are working with R being false. So, since we know that R is false, and Q implies R is true, Q has to be false. Q has to be false. So, if Q is false, and not P or Q is true, then not Q, not P, I mean, where is it? What am I about to conclude? What am I doing here? Guys, help me. Why am I getting lost? Am I getting lost, guys? Tell me. What's the problem with me? I don't know, guys. Help me, guys, please. Please, guys. Okay, it's fine. Let's just redo this, but not everything. Oh, Q has to be false. If Q is false and not P union Q is true, then not P is true. And if not P is true, then P is false. and the statement is invalid. So that's how the flow goes. So hopefully you will get to understand this. Mathematics is very much simple, so you keep on practicing and you all will come. Keep on subscribing, by the way.